So we'll start within 2 minutes. Just waiting for another 2 minutes. Okay, so section A and section B, my slides are visible to both the groups. Okay, okay. So let us start our today's discussion, which is module 7 based on the tachymetric survey. So what is basically tachymetric survey? Can you tell me what are the methods till now you have learned uh, for measurements of horizontal distance? Horizontal distance measure করার জন্য সার্ভিং এ কি মেথড তোমরা লার্ন করেছো?
Chain survey.
Right, chaining or chain surveying. So with the help of chain you will measure the horizontal distance. For vertical distance measurements, what are the surveying you have learned? What are the methods you will apply? Vertical distance measure করার জন্য কোন surveying method শিখেছো?
Leveling.
Right. So we have mainly learned chain surveying and leveling for horizontal and vertical distance measurements, right? And both of them are quite accurate in measuring horizontal and vertical distance. এই চেন সার্ভেইং বা লেভেলিং, ডিফারেন্সিয়াল লেভেলিং, এই দুটো হরাইজন্টাল ও ভার্টিক্যাল ডিস্টেন্স মেজারমেন্টস এর জন্য যথেষ্ট অ্যাকুরেট মেথড। বাট সাপোজ I am doing chaining on an undulated ground, which is not a flat one, then obviously the accuracy will not be that much, right? So accuracy also depends on the typical condition. Now suppose only one method we will apply by which we want to calculate the horizontal and vertical distance both, and also very fast, means we want to measure all the readings with relatively more faster way or more faster rate. Then which method we have to depend on? We have to depend on tachymetry, because in the tachymetry we will measure the horizontal as well as the vertical measurements. However, the accuracy in this method is a little bit less. So precision is a little bit less. Although the method is very fast, you can measure both the horizontal and vertical distance, but the accuracy is little bit less, or precision is also little bit less. If you compare the precision of chaining in normal flat ground, but if you compare the accuracy of chaining in a undulated or flat ground, then we can say that tachyometry's accuracy even more than the chaining. অর্থাৎ চেইনিং এ আমরা ডিজায়ার্ড অ্যাকুরেসি পেয়ে যাই, ডিফারেন্সিয়াল লেভেলিংয়েও ডিজায়ার্ড অ্যাকুরেসি পাই, কিন্তু আমাকে যদি হরাইজন্টাল এবং ভার্টিক্যাল মেজারমেন্টস দুটোই যদি আমাকে করতে হয় একটা সার্ভিং দিয়েই, এবং সেটাও খুব ফাস্টার ওয়েতে, তাহলে আমাদেরকে ট্যাকিওমেট্রিতে ডিপেন্ড করতে হবে। ট্যাকিওমেট্রিতে আমরা হরাইজন্টাল ডিস্টেন্স এন্ড ভার্টিক্যাল ডিস্টেন্স দুটোই মেজার করতে পারবো খুব তাড়াতাড়ি, এবং ট্যাকিওমেট্রিতে অ্যাকুরেসি লেভেলটা নর্মাল যদি তুমি ফ্ল্যাট গ্রাউন্ডে চেইনিং এর যদি অ্যাকুরেসি লেভেল দেখো তার থেকে কম, কিন্তু চেইনিংটাকেও যদি আনডিউলেটেড গ্রাউন্ডে দেখো তার থেকে কিন্তু অ্যাকুরেসি কোনো অংশে কম নয় ট্যাকিওমেট্রি মেথডে। ওকে, সো দিস ইজ all about the tachymetry method. Now how we are doing this? Basically in the tachymetry method we are basically measuring the distance by optical means. So it is one of the optical distance measurements method. How we will do so? Let us proceed, then we will see. So you can see, if this is the undulated ground, if this is your tachyometer, you will see through this tachyometer, and obviously you will get some reading in the staff or the steadier rod, and with just taking these measurements, that means what is the intercept between two you will get actually three measurements like this. You will get three readings in the leveling staff or staff readings. So with the help of these three readings, not only you can calculate the RL of this point, but also you can calculate the distance, horizontal distance of this point from the instrument. So both of these things you can do. Okay, এতদূর অবধি বোঝা গেছে সবার? এই পার্টটা ওকে ওকে। সো ট্যাকিওমেট্রিতে আমরা কি করছি, আনডিউলেটেড গ্রাউন্ডে দেখতে পাচ্ছ একটা ট্যাকিওমিটারকে লাগানো আছে, স্টেডিয়ার রড বা লেভেলিং স্টাফে তুমি তিনটে রিডিং পাবে। এই তিনটে রিডিং দিয়ে তুমি শুধুই যে এই পয়েন্টের আরএল ক্যালকুলেট করতে পারবে সেটা নয়, এই পয়েন্টের হরাইজন্টাল ডিসটেন্স ফ্রম দিস ট্যাকিওমিটার এটাকেও ক্যালকুলেট করতে পারবে। নাও হোয়াট ইজ দ্য ইনস্ট্রুমেন্ট উই ইউজড ইন ট্যাকিওমেট্রি? ফার্স্ট ইনস্ট্রুমেন্ট ইজ ইয়োর ট্যাকিওমিটার. Tachymeter is nothing else but your transit type of theodolite. Okay, so it is basically transit type of theodolite, but where your diaphragm should contain this sort of stadia. Means in your normal theodolite maybe this sort of stadia is not there, only this sort of stadia is also work, or this sort of crosshair will also work. But in tachymeter these three stadia, this is one, This is 2, this is 3. That means 3 horizontal line should be there. This is called, first one is called upper stadia, second one is called middle stadia, and third one is called lower stadia. You can see here all the diaphragms are there, where you can see this upper stadia, middle stadia and lower stadia, all these three are there. You can see 1 2 3, you can see 1 2 3, 1 2 3, 1 2 3, 1 2 3. So upper stadia, lower stadia, middle stadia and lower stadia, these three should be there. So it is, tachymeter is basically nothing else, it is your transit theodolite which is equipped with this sort of special stadia arrangement where you are having this sort of crosshair. Okay, you can see the upper stadia and lower stadia both are at a fixed distance, or at a equal distance from the middle stadia. So this sort of arrangement should be there. Now in this tachyometer, as you know that as it is a basically transit theodolite, so here the theodolite telescope can be either external focusing type normal telescope, or external focusing type analytic telescope, or internal focusing type telescope. Okay, অর্থাৎ ট্যাকিওমিটার তোমাদের আর কিছুই নয়, তোমাদের নর্মাল ট্রানজিট যে থিওডোলাইট যেটা আমরা এতদিন ডিসকাস করে এসেছিলাম, সেই ট্রানজিট থিওডোলাইট, শুধু সেই ট্রানজিট থিওডোলাইটে যে ডায়াফ্রাম থাকবে তার মধ্যে যে ক্রস হেয়ারটা থাকবে সেটা এইরকম অ্যারেঞ্জমেন্ট থাকতে হবে যেখানে আপার স্টেডিয়াম, মিডল স্টেডিয়াম, লোয়ার স্টেডিয়াম যেন থাকে, এটা ম্যান্ডেটারি। সো এখানে দেখতে পাচ্ছ এটা ভার্টিক্যাল ক্রস হেয়ার, এইটা স্টেডিয়া হেয়ার, এটা স্টেডিয়া হেয়ার, আর এটা নর্মাল হরাইজন্টাল ক্রস হেয়ার যেটাকে আমরা মিডল স্টেডিয়া বলতে পারি, আর এটাকে আপার স্টেডিয়া, এটাকে লোয়ার স্টেডিয়া বলতে পারি। ওকে, সো এটা হচ্ছে আমাদের ট্যাকিওমিটার। এরপর আমরা চলে আসবো স্টেডিয়া রড। নাও উই উইল ডিসকাস অ্যাবাউট দ্য স্টেডিয়া রড। স্টেডিয়া রড ইজ নাথিং বাট your level stuff, or you can see it will be almost like your level stuff, this sort of level stuff. Only the thing is that here list count is a little bit larger than your normal level stuff. Here list count will be 1 centimeter. Even in tachyometry also, if you are doing your surveying for a smaller distance, we normally employ level stuff, not your stadia rod, but for a larger distance we employ stadia rod. So stadia rod is simply like level stuff, only the thing is that here your list count is little bit larger. Okay, so that's all about the two things you have to use in the tachyometer. Now you can see whenever you will look through the telescope, you can see this sort of things. You will see there is the middle stadia or your horizontal crosshair. This is the upper stadia and this is the lower stadia. So we will take the reading of all these three, right? Like say 2.12, here say 0.9, like this. Means I'm not saying all these three readings you have to take. Okay, অর্থাৎ আমরা দেখলাম যে স্টেডিয়া রড সেটা কিছুই না, সিমিলার লাইক লেভেল স্টাফ, only the difference is that in স্টেডিয়া রড কি হবে, the list count is little bit larger. So স্টেডিয়া রডে লিস্ট কাউন্টটা একটু বড় শুধু, তাছাড়া এটা লেভেল স্টাফের মতোই কাজ করে, লেভেল স্টাফের মতোই দেখতেও। সো আমরা কখন লেভেল স্টাফ আর কখন স্টেডিয়া রড ইউজ করব, যদি আমরা খুব স্মলেস্ট ডিস্টেন্স সার্ভে করি। If we survey only a very small distance, then we will use the level stuff so that our accuracy will be much more higher. But if we go for a larger distance, we can use the stadia rod. Okay, now we will discuss about the methods of the tachyometry. In tachymetry we normally use these three sort of method: Steadier method, tangential method and special instrument method. Steadier method is more common or more popular, I can say, than the other two methods. Now if we say Steadier method, then also in Steadier method you are having fixed hair method and movable hair method. But normally fixed hair method is the most popular one, and normally by Steadier method also we mean ফিক্সড হেয়ার মেথড। তাহলে ট্যাকিওমেট্রির তিনটে মেথড আছে। এক নম্বর হচ্ছে স্টেডিয়ার মেথড, দুই ট্যানজেন্সিয়াল মেথড, তিন স্পেশাল ইনস্ট্রুমেন্ট মেথড। স্টেডিয়ার মেথডের আবার দুটো পার্ট আছে, একটা ফিক্সড হেয়ার মেথড, একটা মুভেবল হেয়ার মেথড। ফিক্সড হেয়ার মেথডটাই আমরা নর্মালি পপুলার, এবং নর্মালি স্টেডিয়ার মেথড বলতে আমরা ফিক্সড হেয়ার মেথডটাকেই বুঝি। সো হেয়ার হোয়াট উইল হ্যাপেন, your stadia, that is upper stadia and lower stadia, is fixed at certain distance. These two are not movable. So if this two is fixed here, so obviously when you will look through your telescope, what will happen, your staff reading, that is upper stadia's reading, middle stadia's reading and lower stadia's reading, your reading will change depending on the distance, because this is nothing but similar triangle, right? So your middle stadia reading will be constant, but your upper stadia and lower stadia reading will change. Now we call this difference between this reading, that is upper stadia minus lower stadia, this is called staff intercept. Staff intercept. So this staff intercept also will change. That means this base of this triangle also will change depending on the height, because we know in this similar triangle, height to base, this ratio is constant, right? So S1 by D1 will be equals to S2 by D2 will be equals to S3 by D3. So this is the main funda of Stadia method, or main principle of Stadia method. That means in Stadia method, basically your Stadia method, we are basically using this concept of the similar triangle, okay, where the base to height, this ratio is constant, okay. So staff intercept will be much more if your staff, the point where you are holding the staff is at a much higher distance. So if your D is higher, your S will be also higher, okay. Now what we will do, we can directly from this method, what we will do, we will take this upper stadia, middle stadia and lower stadia reading. From upper stadia and lower stadia reading, we can calculate the staff intercept, which is also called S, as denoted here, S1, S2, S3. And depending on this S, we can calculate the D, because it follows a special relation which is called D equals to Ks plus C, where K and C both are constant for a typical tachyometer or for a typical lens. So if you measure the S, you can easily calculate the D, right? Now then, why middle stadia reading is taken? Because middle stadia reading, from middle stadia reading, you can calculate the RL of each point where you are holding your staff. So vertical measurements, for vertical measurements, middle stadia reading is important, and for horizontal measurements, your upper stadia and lower stadia reading is important. তাহলে স্টেডিয়াম মেথডে কি করব, আমরা ডিফারেন্ট স্টেডিয়াম মেথডে আমাদের দুটো যে ক্রস হেয়ার, আপার স্টেডিয়া এবং লোয়ার স্টেডিয়া, এই দুটো যে স্টেডিয়া, সেই দুটো ফিক্সড থাকবে আমার ডায়াফ্রামে, এট এ ফিক্সড ডিস্টেন্সে থাকবে। এরপর আমি যদি এটা দিয়ে দেখি এবং আমার স্টাফটাকে যদি আমি একটা ডিস্টেন্স পর পর হোল্ড করি, তাহলে সেই স্টাফের আমরা তিনটে করে রিডিং পাবো, যেখানে আপার স্টেডিয়াটা একটা পয়েন্টে কাট করবে, মিডল স্টেডিয়াটা একটা পয়েন্টে, লোয়ার স্টেডিয়াটা একটা পয়েন্টে। যদি আমি আপার স্টেডিয়া এবং লোয়ার স্টেডিয়ার ডিফারেন্স নিই, সেটাকে আমরা বলবো স্টাফ ইন্টারসেপ্ট। এই স্টাফ ইন্টারসেপ্টে জানলে আমি যে পয়েন্টে স্টাফটাকে ধরে রেখেছি সেই পয়েন্টের ডিস্টেন্সটা পেয়ে যাব, কারণ আমরা এই রিলেশনশিপটা জানি যে D equals to Ks plus C, where K and C is constant for a typical tachyometer, okay. তাহলে এসটাকে মেজার করলেই আমরা ডিটাকে মেজার করতে পারবো। তাহলে অন্য একটা পয়েন্টে গিয়েও আমি যদি হেল্ড করি স্টাফটাকে, অন্য আমি ডিফারেন্ট আপার স্টেডিয়া এন্ড লোয়ার স্টেডিয়া রিডিং পাবো, তাদের ডিফারেন্স থেকে এগেইন আমি ডিসটেন্সটা ক্যালকুলেট করে নিতে পারবো। তাহলে হরাইজন্টাল ডিসটেন্স মেজারমেন্টস এর জন্য আমার কোন দুটো ইম্পর্টেন্ট, আপার স্টেডিয়া এন্ড লোয়ার স্টেডিয়া এন্ড দেয়ার ডিফারেন্স। অ্যান্ড ভার্টিক্যাল আরএল এর জন্য আরএল ক্যালকুলেট করার জন্য অবশ্যই আমার মিডিয়াল স্টেডিয়া রিডিংটা লাগবে, যেটা এতদিন অবধি আমরা ডিসকাস করলাম লেভেলিং পার্টে। ওকে, সো ইজ দিস পার্ট ক্লিয়ার টু অল অফ ইউ? মিন্স হাউ উই উইল ডু, ইজ দিস পার্ট ইজ ক্লিয়ার টু ইউ? সবার কাছে কি এটা ক্লিয়ার হয়েছে যে কিভাবে মেজার করব? এই বেসিক প্রিন্সিপালটি কি বুঝতে পারছো?
Yes, sir.
ওকে, বোঝা গেছে সবাই? ওকে ওকে। Now, in the movable hair method, which is also called subtense method, this is also another Stadia method. But normally, if anyone say we will do by Stadia method, then we will not mean this method. We will go by this method. Okay. Here, what will happen? Here, the target is fixed. Suppose in the staff you want to bisect the height where 2 meter reading is there, and you want to bisect the staff reading where 1 meter reading is there. But your upper stadia and lower stadia is movable, so that is changeable, and we will make the arrangement in such a way that upper stadia will cut this reading, lower stadia will cut this reading. And it is also possible to measure this difference. That means in the diaphragm, or where the upper stadia and lower stadia is there we can measure the difference, not in the staff. So in the staff, obviously you are getting these measurements as your points are prefixed, so the difference you will get, and here also you will get the difference. So by applying the trigonometry, then you can calculate, because suppose this is your one triangle, this is your another triangle. So obviously you know this reading, you know this reading, and you know this reading also. Then you can calculate the distance by applying trigonometry. So this is called movable hair method. Okay. Now then there will be tangential method. These two methods also we will discuss in the next day. At that time it will be clear to you, it will be much clear to you when we will discuss with the examples. But for this time being, please note that here the stadia hairs are not fixed, and the distance are also not means constant. So obviously this distance can change, and we can measure that distance also. Okay. So that will be in the movable hair method. In the tangential method, here even the stadia hairs are not in used. That means we will not use the stadia hairs. We will only use the horizontal crosshair, or which we normally call as the middle stadia, which is actually our horizontal hair. Only that one we will use. Now, how we will measure then the distance? Simply, what we will do, with the help of the tachyometer, we will sight 2 times. At a single point, the staff will sight 2 times with different angle. So your base is constant. So you can see, if you apply the trigonometry, your base is constant. Okay, and you are sighting to different point. So this base is constant, your angle too is different, and your height is different. So by applying trigonometry, then we can calculate this distance also. So that is the basic principle of tangential method. Here we will not use the upper stadia and lower stadia. অর্থাৎ upper stadia and lower stadia কে এই tangential method এ আমরা ইউজ করব না। সিম্পল আমরা একটা প্লেসেই স্টাফকে আমরা দুবার টার্গেট করব, ঠিক আছে, দুটো পয়েন্টে। তাহলে আমার বেস ডিসটেন্সটা কনস্ট্যান্ট, আমার হাইটটা শুধু চেঞ্জ হচ্ছে, যার জন্য অ্যাঙ্গেলটাও চেঞ্জ হবে। তাহলে আমি দুটো ট্রিগোনোমেট্রির কন্ডিশন থেকে কি পাবো? আমরা বেসটা বের করে নিতে পারবো খুব ইজিলি। আমরা ট্রিগোনোমেট্রির লসকে শুধু অ্যাপ্লাই করব, তাহলে আমরা সেই বেসটাকে ইজিলি ক্যালকুলেট করে নিতে পারবো। তো এইভাবে আমরা ট্যানজেন্সিয়াল মেথড দিয়ে ট্যাকোমেট্রিও করতে পারি। ওকে, ক্লিয়ার এই দুটো মেথড? মানে বেসিকটা কি বুঝতে পারলে? প্রিন্সিপালটা উইল ডিসকাস ইন ডিটেইলস অন দ্য নেক্সট ক্লাস, বাট প্রিন্সিপাল ইজ ক্লিয়ার অর নট? নাকি বুঝতে পারবে?
স্যার আরেকবার একটু বলে দেবেন?
ওকে ওকে, নট এ প্রবলেম। কোনটা, শুধুমাত্র ট্যানজেন্সিয়াল মেথডটা নাকি মুভেবল হেয়ার মেথডটাও বুঝতে পারবে?
স্যার শুধুমাত্র ট্যানজেন্সিয়ালটা।
ওকে ওকে। In the tangential method, what we will do, suppose we want to measure the vertical and the horizontal distance, right? So for vertical RL measurements, there is no problem. You will, with the help of the tachyometer, you will sight the, suppose the ground point here is B and this is A point. Now for B point you want to determine the RL. You will just, with the help of the horizontal crosshair, or which we call middle stadia, with the help of that we will simply target the staff held at B. অর্থাৎ বি পয়েন্টে আরএল ক্যালকুলেট করতে গেলে বি পয়েন্টে আমি স্টাফকে ধরবো, এ পয়েন্ট থেকে আমার ট্যাকিওমিটারকে তাক করব বি পয়েন্টের স্টাফের দিকে, তারপর আমি হরাইজন্টাল ক্রসহেয়ারের রেসপেক্টে বা মিডল স্টেডিয়ার রেসপেক্টে আমি রিডিংটা নিয়ে নেব। আমি সেটা দিয়েই আমি করে ফেলতে পারবো বি পয়েন্টের আরএল মেজারমেন্টস। কারণ কি, আমি তো হাইট অফ কলিমেশনটা আগে ডিটারমাইন্ড আমার, তাহলে আমি আরএল ক্যালকুলেটে আমার কোনো প্রবলেম হবে না। The problem is in calculation of the horizontal distance. So how we will do if we are not employing the Steadier method? Just wait for 1 minute. অর্থাৎ আমরা যদি স্টেডিয়া মেথডটা অ্যাপ্লাই না করি তাহলে ডিসটেন্সটা কিভাবে মেজার করব? আমরা কি করব, একবার এটা দিকে ধরো তাক করলাম একটা অ্যাঙ্গেলে, রাইট? এই টাইমেও ডিসটেন্সটা কিন্তু সেম, এইটা হচ্ছে ডিসটেন্স ইনস্ট্রুমেন্ট থেকে আমার স্টাফের ডিসটেন্স, this one is the D distance between the instrument and the staff, and this reading is say H1 and say this angle is theta1. Now with the help of that instrument also at the same position, what we will do, again we will bisect or try to, we will take a reading of this staff which is held at B at a different angle, say at theta2. So obviously your height will change but your base is same. So by applying these two method you can calculate the D. Okay,
Okay, sir.
by applying these two method you can calculate the D. Is that clear?
Yes, sir.
বুঝা গেল?
হ্যাঁ স্যার।
Okay. So we will discuss in detail on the next class. At that time it will be much clearer. So the first method, which is the most important method, that at first we will discuss. Okay, so it is called the principle of Steadier method. So the Steadier method we will discuss at first, and its principle we will discuss. As I have told you in the very first two slides, that in the Steadier method we will apply the concept of similar isosceles triangle, right? Similar triangle or similar isosceles triangle. So what we will do, you can see at different point we are holding our staff. Okay, so if your upper stadia reading is corresponding to A point, your middle stadia reading is corresponding to C point, and your lower stadia reading is corresponding to B point when your staff is held at D1. Similarly, if you move your staff at D2 distance, I don't know what is D1 and what is D2. I will calculate this D1 and D2 based on this only the staff reading. I will not do chaining and all these things. This method is obviously not employing chaining. That's why this method is much more faster method. I will just hold my staff in a particular place, and I will just note down the upper stadia, lower stadia and middle stadia reading, and I will calculate the distance and also the RL of that particular point. So suppose at D2 distance, which we don't know, I will hold my staff, and there also I am getting 2-3 readings, upper stadia, middle stadia and then lower stadia reading. Then again at D3 point, if I am placing my staff, I will get upper stadia, middle stadia and lower stadia reading. With the difference, if I can calculate between upper stadia and lower stadia, I can calculate the S1 or the staff intercept at place 1. Here also I can calculate the staff intercept, which is H2, which is basically upper stadia and lower stadia reading, upper stadia minus lower stadia reading. Similarly, here also I will get that S3 or the staff intercept. Now what I can do, I can simply employ the formula and I can calculate the D. But where from this formula is coming, those things will be discussed first. So if you look at this triangle, let us see this triangle. Sorry. So these are the triangle, as you can see. So this is O, this is A, this is B, this is A dashed, this is B dashed, and that is B double dashed, A double dashed. Now here what will happen, if you see for this triangle, this small part AOC, this small part of the triangle, this smallest triangle, and if you see this total angle is theta, then this small angle will be theta by 2, right? Now if you calculate from this triangle, as this is 90 degree, if you calculate from this triangle tan of this theta by 2, then that will be AC by OC. Am I right? Is it clear? From this triangle, tan of theta by 2 is equals to AC by OC. Is that clear to everyone? Clear holo sabar kache? Okay, now if you take the little bit larger one, that is O A dash B dash, this triangle, or O A dash C dash, this triangle, if you take, then from that triangle you can write tan theta by 2 is equals to AC dashed by OC dashed from this triangle. From this triangle, if you see O A dash C dash, if you write AC dash by OC dash, that also will be equals to tan theta by 2. Similarly, for the bigger one, that is O A dash C double dashed, you can write tan theta by 2 equals to AC double dashed by OC double dashed. So all these three values are same. That's why it is written AC by OC will be equals to AC dashed by OC dashed will be equals to A dashed C dashed by OC dashed will be equals to A double dashed C dashed C double dashed A double dashed C double dashed by OC double dashed is equals to tan theta by 2. So I guess the first line is clear. It is simply for each triangle we have noted down the perpendicular by base, this ratio, which will be equals to tan theta by 2. That is what we have written. Is it clear to everyone, this first line? I guess that is clear, right? Is it clear to everyone?
Yes, sir.
Now what we will do, AC, which we can write, that will be AB by 2. Why? Because always your upper stadia and lower stadia is at same distance. We are discussing for the stadia method or that fixed stadia method, right? The first method. So your upper stadia and lower stadia will be at a fixed distance or at a equal distance. So obviously your AC will be equals to CB, your AC dash will be equals to C dash B dash, your A double dash C double dash is equals to C double dash B double dash. So obviously your AC, in place of AC you can write AB by 2, in place of A dash C dash you can write A dash B dash by 2, in place of A double dash C double dash you can write A double dash B double dash by 2. So I guess this line is also clear. Now what I can write simply AB by OC. From this line I can write, you can see AB by 2 by OC, which I can write AB by 2 OC is equals to tan theta by 2. From here I can write AB by OC equals to 2 tan theta by 2, right? In the similar way, I have written, from this I have written AB by OC, from this I have written A dash B dash by O dash OC dash, and from this I have written A double dash B double dash by OC double dash, and all of them will be equals to 2 tan theta by 2. So I guess this line is clear to everyone. সবার কাছে এটা clear? এটা clear to?
Yes, sir.
Yes, sir.
Okay. Now what we will do, we will just inverse the whole equation. We will just take the inverse. So just simply you just change the place of the numerator and the denominator. So what will happen? If from this, if you want to write this equation, OB AB by OC, so you are doing OC by AB. So it will be OC dashed by A dash B dash. It will be OC double dash by A double dash B dash, and it will be 1 by 2 tan theta by 2. And that's why I have written half 1 by tan theta by 2, that means cot theta by 2. So half cot theta by 2. Now for a particular instrument, that theta is fixed. That means this angle is fixed for a particular instrument. Instrument is made in such a way that this theta will be fixed. So if theta is fixed, or half tan theta, cot theta by 2 is fixed. If theta is fixed, half cot theta by 2 also will be fixed. And that we are terming as constant k. As this is constant, so we are writing this equals to constant k. Now, normally what will happen to calculate OC, if our constant k will be a constant in such that our calculation will be much faster, we can make this constant 100. If we want to make this constant equals to 100, or simple OC by AB ratio as 100, we have to prefix this angle at some value, and that's why in some of the lenses this theta is fixed at an angle of 0 degree 34 minutes 22.63 seconds. If you apply this theta value, you can see, or you can calculate, half of cot theta by 2 will come as 100. You can check this one. Okay, if theta is specified in the where the instrument is made, or the company which is making this instrument, if they are specifying this theta as 0 degree 34 minutes 22.63 seconds, then your value of k will be 100. If your theta will differ than this angle, so obviously your k value also will change, right? Your k value may be 95.632, your k value may be 96.78, like this. If you are mentioning to make this angle but you are not able to make this angle, so obviously some kind of error will be there. But if your angle will be nearly this one, your k value will be nearly 100, and if it is 100, it will be easier to calculate the OC value, because you will only take the staff intercept, you will multiply by the 100 and you will get the distance, right? Are you getting my point? বোঝা গেল? থিটাটাকে যদি আমরা 0 ডিগ্রি 34 মিনিট এবং 22.63 সেকেন্ডে ফিক্স করতে পারি, তাহলে আমাদের কি হবে? হাফ কট থিটা বাই 2 এর ভ্যালুটা 100 আসবে। 100 এলে কি হবে? আমাদের ক্যালকুলেশনটা ইজিয়ার হয়ে যাবে। আমরা জাস্ট স্টাফ ইন্টারসেপ্টটা ক্যালকুলেট করব, 100 দিয়ে মাল্টিপ্লাই করব, আমরা হরিজন্টাল ডিসটেন্স পেয়ে যাব। বোঝা গেল?
Yes, sir.
Okay. So that is the principle of the Steadier method. Remember, this k value will not be equals to 100 for every lens, hence the k value will change. Okay. Okay, this is the distance and elevation formula which we will derive for a Steadier method, for the Steadier method. So suppose this is the objective lens which you are having in your telescope. Okay, then suppose from O is the optical center, and this is the position where you are holding your staff, and AB is the staff intercept. AB is the staff intercept, or upper Steadier reading is A, your lower Steadier reading is B, and middle Steadier reading is C. Now all this I have told already in the theodolite at the time of the theodolite also, at the time of the leveling, sorry, not the theodolite, at the time of the leveling also, that it will create an image at the plane of the crosshairs. So say it is creating an image of AB here, and the length of the image is I. Okay. Now, the distance of the image or the crosshair from the optical center is V, and the distance of the object or the staff from the optical center is U. Now, if F is the focal length of this objective lens, then we can write 1 by F is equals to 1 by U plus 1 by V. We have studied this formula in class 11-12 physics. Okay, এই কার মাইকটা অন আছে একটু অফ করো তো, কিছু কোশ্চেন আছে কি তোমার? Okay, so we can simply apply this lens formula 1 by F is equals to 1 by U plus 1 by V. Now before applying this formula from this similar triangle, these two triangle is also similar triangle. This is S, this is I, and this is your V, and this is U. So from this triangle also we can write that this I by U will be equals to S by, sorry, I by V will be equals to S by U. Now from this you can write U by V will be equals to S by I, right? From this triangle, as these two are similar triangle, so you can write I, that is the perpendicular here, and S, which is the perpendicular here. So I by the base V will be equals to the perpendicular here S by base U. That you can write I by V equals to S by U, and from that you can write, just if you do the cross multiplication, if you just change the place, then what will happen? U by V is equals to S by I. So you know this, that U by V is equals to S by I. Now we will come to this equation, the length equation, that is 1 by F is equals to 1 by U plus 1 by V. Now in this equation, if you multiply the left hand and right hand both the side by FU, F and U, then in the left hand side, if you multiply 1 by F by FU, F will cancel out, E will be there only. Similarly, when you will multiply the right hand side by Fu, in place of 1 by U will cancel out, F will be only there, and when you will multiply 1 by V by Fu, it will be simple F into U by V. Now in this equation, if you just substitute the value of U by V, which is equals to S by I, if you substitute that value, this equation will become U equals to F plus F into, instead of U by V, you are writing S by I. So you will write F into S by I. Now from this part, if you take S out, and you can just write F by I, that you can write. So I am writing U is equals to F plus S into F by I. So that I can write. Now remember, the distance between the axis and the staff, axis of the instrument and the staff, which is capital D, and that will be how much? That will be your small u plus small d. And how you will calculate that? You small u value you have calculated, you will replace that one, that is F plus S into F by I plus D. Here this equation you can write as F by I into S, this part, plus F plus D, that part in the bracket. Now this f by I, we are terming that as k, and this f plus d, that we are terming as c. So k we are terming basically f by I and c as f plus d. This k is called multiplicative constant and c is called additive constant. Now this small f plus d, this value will be very minimum, because you can see the d value is within the your instrument, and it is the distance between the optical center and the axis of the instrument, which will be very minimum, right? And f is the focal length of the objective lens. So c will be very minimum, will be nearly 0.25 to 0.35, whereas your k, which is multiplicative constant, will be nearly 100. Okay, nearly 100, I'm not saying exactly 100. So ultimately your equation will become d equals to ks plus c. Hence you can calculate any distance where you are placing your staff just by knowing the c or the staff intercept. Is that clear to everyone?
Yes.
বুঝতে
Yes.
পারলে? Yes sir. Okay. Now, how to calculate the elevation of the staff station? That means RL of this point. That will be simply calculated if you know the height of the instrument or the elevation of the line of collimation. You will, from that you will deduct this reading, and this reading you will get from the medial stadia or simple horizontal crosshair. If you, or it is written also central hair reading. So if you deduct that central hair reading from the elevation of the horizontal instrumental axis, or which is also called height of the instrument, which is also called elevation of the line of collimation, from that if you deduct your middle stadia reading, you can easily calculate the RL of this point. So that's how we will calculate the distance and elevation by only tachyometer. We are not doing chaining. Okay? The process is clear? So suppose this is a ground. You can see this is an undulated ground, where by chaining with much accuracy you are not able to calculate the horizontal distance also. But here you can apply the tachymetry method. What you will do, your friend, you are suppose here, you are looking with the help of this tachyometer, through this tachymeter you are looking, and your friend is going with this level staff or steadier rod, and he is placing at P. Suppose you want to note the distance and the elevation of this point P. So you will just এই কে অন করেছো একটু স্টপ করো। সমজিৎ, তোমার রেন্ট থেকে একটু আওয়াজ আসছে, একটু অফ করো তো। Okay. So now what you will do, your friend will go with this level staff, and suppose he is placing your this level staff or steadier rod at P point. You want to determine the distance and the RL, the distance of this P point, that is horizontal distance from the instrument, and also the RL of this P point. So how we will calculate? You already know this elevation of the line of collimation or the height of the instrument, which we have discussed in the leveling also. So what you will do? You will simply see through this telescope. You will note down the upper stadia, middle stadia, and lower stadia reading. From the upper stadia and lower stadia reading, you are able to calculate the staff intercept. But if you have calculated the staff intercept, and if you know the multiplicative constant and the additive constant of this instrument, then you can easily calculate the distance by applying this formula, right? Similarly, as you have also noted down the middle stadia or central hair reading, you can calculate the RL of point P just by deducting your middle stadia reading H1 or the central hair reading H1 from the height of the instrument. So both the distance and RL you can calculate just by noting down these three stadia reading. Is that clear to everyone? কিভাবে করলাম ক্যালকুলেশনটা? সবার বোঝা আছে? কারো কোনো অসুবিধা নেই তো? অসুবিধা থাকলে বলো। ট্যাকোমিটার বুঝতে। সৌভিক প্রামাণিক বুঝতে পেরেছো? তুমি তো আগের দিন ছাড়াই দিলে না। সৌভিক প্রামাণিক, ওকে। প্রবাল বুঝতে পেরেছো?
Yes, sir.
Ayush Tamam, are you there? Ayush Tamam?
Yes, sir.
Is it clear?
Yes, sir.
Okay. So in similar fashion, we have to just go and place our staff, and we will note down the upper stadia, lower stadia, and middle stadia reading, and we can calculate the distance as well as the elevation. So it is much more faster method, okay, of calculating the RL as well as horizontal distance. So now similar type of example is given here. Suppose you are observing through this telescope. You are observing through this telescope, and your friend is holding the staff at point P. Now suppose you know the RL of point N. RL of point N is 200 meter. Physical height of the instrument at point N is 0.875 meter, and the staff reading at P, where your friend is holding this staff, the staff readings at point P are 0.62 meter, 625 meter, 0.5 meter, and 0.375 meter. That means this is the upper stadia reading, this is the middle stadia or central hair reading, and this is the lower stadia reading. So all this reading you have noted down. Now you want to calculate the distance of this point P from point N, or simply the station point P's distance, horizontal distance from the instrument station you want to calculate. You also want to calculate the RL of point P. Okay, so if you have understood till now the whole process, you can easily calculate just by applying tachyometric principle. Also, for this instrument, multiplicative and additive constants are given. Same multiplicative constant is 9.98.15, and additive constant is minus 0.523 meter. So calculate from this. So first what we will do, কোশ্চেনটাকে আগে নোট ডাউন করো সবাই, বা ডেটাগুলোকে অ্যাটলিস্ট নোট ডাউন করো, বা অ্যাটলিস্ট এই ডায়াগ্রামটাকে নোট ডাউন করো। একটা পার্ট একটা স্টাডি অবধি করলেই হবে, কারণ বাকি দুটো ডেটা মানে একটা স্টাফের রিডিং অবধি করলেই হবে। Just draw this diagram up to this P. You don't have to draw Q and R because for those data is not given. Okay, and note down the data like this: upper stadia, middle stadia, and lower stadia reading. Once you are done, please let me know. We will do these small numericals to understand the process.
Done, sir.
ওকে, সবার হয়েছে লেখা? কারো বাকি নেই তো? আমি
না
তাহলে
স্যার।
ওকে ওকে
একটু দাঁড়ান।
আচ্ছা আচ্ছা। Okay. So now, as we have noted down the upper stadia, middle stadia, and lower stadia reading. First, what we will do, we will calculate the staff intercept, and that will be simple: upper stadia minus lower stadia. So calculate staff intercept, that is 0.625 minus 0.375. That much of meter. Calculate. ক্যালকুলেট করে বলো কত আসছে।
Sir, 0.25.
Right. So 0.25 meter. Now, as K and C both are given, so we can calculate the D. It will be simple. K is plus C. K is given as 98.15. K is given as 98.15. S is given as S is we have calculated from the observed data, that is 0.25, and C is given as minus 0.523. So calculate.
So the 24.01.
24.5375.
24.0145.
Yes, sir.
0145. Okay. So this is the distance of point P. So this is the distance of point P. Now we have to calculate the RL of point P, and that we know simple: height of instrument minus the middle stadia reading. So minus H1. Now height of the instrument we can write that RL of N plus the ON. RL of N plus ON. ON is the physical height. So RL of N is given 200 meter plus ON is the physical height of the instrument is given as 0.875 meter, and H1 is given as 0.5 meter. So calculate the RL of point P.
So 200.37.
200.37.
5.
375.
375.
So that means these points RL is 200.375 and this distance is 24.0145. So you can see how easily we can calculate. Just you have to note down this 3 stadia reading. By this you can calculate the RL as well as distance. You don't have to lay chain, you don't have to measure the chaining and all these things. Then chaining also you have to be sure so that there will not be sagging and all these things to minimize the error, right? But you don't have to do anything like this here. You have to be you can just keep the stuff in a normal vertical way and you can easily calculate. So this is very faster method of calculation. Okay, only you have to know the multiplicative and additive constant of that particular instrument. Okay, so is that clear to everyone? Can I move to the next slide? সবার ক্লিয়ার তো
Sir,
সবার কাছে?
sir, RL টা আরেকবার বলে দিন তো।
RL is simple. RL of this point is simple: height of the instrument or the line of or the height of the instrument means not the physical height. I have discussed so many times in the leveling chapter. Height of instrument means the elevation of the line of collimation of this line from a particular datum. So this is HI. Now, if you know this height and if you know this small height also, then you can calculate easily from this datum at which height the point P will be, or simply the RL of P you can easily calculate. If you know the height of instrument and this H, how we will calculate? RL of P will be height of instrument minus small h, right? Now this height of instrument, how we will calculate? As these points benchmarks RL is given, you can just add the physical height of this instrument, because RL of this point is also with respect to a particular datum. If you know this plus this one, obviously then you are getting the height of this line or line of collimation from the datum, right? That's why instead of height of instrument I am writing RL of point N plus ON. Is that clear? বোঝা গেল?
And sir, H1?
H1 is the middle stadia reading you are getting at this staff. এই যে H1 টা P থেকে যে এই যে মিডল স্টেডিয়া অবধি, এই যে P পয়েন্ট থেকে স্টাফটাকে হেল্ড করেছো, তাহলে P পয়েন্টে 0 রয়েছে স্টাফের, আর সেখান থেকে স্টাফটা যেখানে কাট করছে, এই মিডল হেয়ারটা যেখানে কাট করছে স্টাফের, সেই রিডিংটা H1। বোঝা গেল?
থ্যাংক ইউ স্যার।
সেটা পেলেই তুমি সেটাকে বাদ দিয়ে দিলেই, এই লাইনটার হাইটের থেকে যদি H1 টাকে বাদ দিয়ে দাও, তাহলেই তো P পয়েন্টের হাইটটা পেয়ে যাবে, তাই না? কোথা থেকে হাইটটা পাবে? একটা ডেটামের রেসপেক্টে। বোঝা গেল?
হ্যাঁ স্যার, বুঝতে পেরেছি।
Okay. So now we will discuss the case where the staff is vertical. See, here the staff is vertical. Here also the staff is vertical. But your side is inclined. Your side is previously the cases we have discussed. Your side is also horizontal. So D equals to Ks plus C, this formula is valid when your staff is vertical as well as your side is also horizontal. But if your staff is not vertical or your side is not horizontal, then the case will change. And there may be some cases where this sort of arrangements will be there. So for that also, this formula will change a little bit. So that's what we have to discuss right now. So if your staff is held vertical but your side is inclined, so your side is previously horizontal but right now it is inclined, so then what will be the case? So you can see your middle stadia reading will be C corresponding to, your upper stadia reading will be corresponding to A, and your lower stadia reading will be corresponding to B. So A, C, B, these readings you will get. Okay. Obviously, this ACB or vertical staff and this line, this angle, that means if you see ACB and this middle stadia reading, this angle is not 90 degree. So at 90 degree, if you place one, you draw an surface A dash B dash, then you can write A dash CO, this angle as 90 degree, right? Now, once you are sure that your inclination or simply your side is inclined, it will be inclined at some angle, so that angle is theta, and in between angle, this small angle is alpha, which previously we have denoted as theta also. So this angle we are denoting as alpha. That is the normal theodolite's lens's angle, which is ideally very less, alpha, which is very small, 0 degree, 18 minutes, 11 minutes or something like that. This data is there. So in that case, in this case, how we will measure? How we will measure the actual distance? So for that reason, what we have to do? We have to first look at this triangle. You can see OCF, this part, OCF. So if you look at this triangle, this is O, this is C, and this is F. F is the extended portion of this vertical staff and the horizontal line. If I extend, from O to F. So this angle obviously will be 90 degree. So if this is 90 degree, we know this angle is theta. Theta is the angle of inclination. This angle we know, right? This angle we know as theta. So obviously this angle will be 90 degree minus theta. Right? So this angle, that is OCF, is equals to 90 degree minus theta. Instead of OCF, we can write OCB also, because they are denoting the same angle, 90 degree minus theta. Instead of OCF, we can write OCB also, they are denoting the same angle. Now if you take this small triangle, not small triangle, the larger one, if you take, just this large triangle, if you take, where O C B dashed is there, this triangle OCB dashed is there, then we know this is 90 degree, angle OCB is 90 degree, OCB dashed is 90 degree. Now in OCB dashed, which is 90 degree, OCB dashed we can write as angle OCB plus BC B dashed. OCB dashed is 90 degree, so we can write that OCB dashed as a summation of this angle plus this small angle. So that will be 90 degree. But we know that angle OCB is 90 degree minus theta. So angle BCB dashed will be 90 degree minus angle OCB. So 90 degree minus 90 degree minus theta. So it will come as theta. That means this BCB dashed, this small angle, if you look at this point, this is C, this is A dashed, this is B dashed, this is B. So this small angle, this is also theta, and this is ACA dashed, this is also theta. So that the thing we have got. Now, if you have understood this, that means the smallest part of the angle, this smallest part of the angle is theta, this smallest angle is theta, then we will move to now these triangles, COA dash, all this. Okay, so now we have got this information. Now let us check this part. COA dashed, COB dashed, these two are equal angle. This is C, this is A dashed, this is B dashed, and this is O. So this is alpha we have denoted. So COA dashed and COB dashed, these two are equal angle, and COA dashed will be alpha by 2. As this is the whole one is alpha, so COA dashed will be alpha by 2. Now if this is alpha by 2, then from this triangle you can write, as this is 90 degree, you can write this is alpha by 2. Then from this upper part of the triangle you can write this angle will be 90 degree minus alpha by 2, right? So C A dashed O, this will be 90 degree minus alpha by 2. C A dashed O, this angle will be 90 degree minus alpha by 2. Now if that angle is 90 degree minus alpha by 2, then C A dashed A, simple C A dashed A, and here in this side O is there. So this angle, that is C A dash O, that is 90 degree minus alpha. Then this one will be how much? 180 degree minus 90 degree minus alpha, this part, 180 degree minus this part. So then that will become 90 degree plus alpha by 2. Okay. So 90 degree plus alpha by 2, this is the C A dash A angle. But if you have remember that always we try to make k as 100, although k will be not equals to exactly equals to 100, but to make k equals to 100, we specified that alpha should be 0 degree 34 minute 22 second. Hence alpha by 2 will be 0 degree 17 minute 11 second. So the value of alpha by 2 is very small. That's why C A dash A, this angle, although it is 90 degree plus 17 minutes something, because ultimately alpha by 2 is 0 degree 17 minutes 11 second, like this. But we are not considering that value, we are approximately considering that as 90 degree. Okay. So we are considering that angle also as 90 degree. Now, if you consider that angle as 90 degree, then if you see this small triangle part, that is A dash C, although it is, sorry, it's not like this. So A dash A C, although this angle is 90 degree plus alpha by 2, but almost we are considering it as 90 degree. So if you consider that angle as 90 degree, then what will happen? Please check. And this angle is theta, because this angle we have determined previously. Here we have determined that this angle is theta. So from this, you can write easily the value of A dash C. The value of A dash C, you can write easily. That will be how much? If you know the value of AC. If you know the value of AC, you can easily calculate. So if you know the value of AC, say this AC, you can easily calculate. Because for this theta, if you take the cos theta, if you from this triangle, if you take the cos theta, for your better understanding, I am drawing like this. This is the theta, this is C, this is A, and this is A dashed. So your S is basically AC, this part, and A dash, this part you have to determine A dash C. So how will determine? If you take cos theta, then it will be, some people have curly brown hair, right? So base by hypotenuse. So base is A dash C by AC is the hypotenuse. So A dash C will be AC cos theta. A dash C will be AC cos theta from this small part of the triangle. From this small part of the triangle, A dash C will be AC cos theta. Similarly, from this small part of the triangle, we will get B dash C is equal to BC cos theta. Now, why we are determining A dash C plus B dash C? Because we want to determine this length instead of this one. This one, AB, we are getting because of the steadier reading, but we want to calculate the A dash B dash. So A dash B dash will be A dash C plus B dash C. Okay. So A dash C plus B dash C. A dash C plus B dash C. So A dash C plus B dash C, we will just put in place of A dash C, we will put AC cos theta. In place of B dash C, we will put BC cos theta. But AC and BC are normally equals because those are the steadier reading S. So, or you can, those are the steadier reading S by 2, because upper stadia minus lower stadia, that is upper stadia minus lower stadia will be the reading AB. So that will be S. So AC plus BC, this part, this AC plus BC, this will be simple the steadier reading. And that's why if you take the common cos theta will take the common, it will be AC plus BC, and in place of AC plus BC you can just write S. So it will be simple S cos theta. So your A dash B dash will be S cos theta, and depending on this we will modify our equation, we will modify our calculation. So if you see in this diagram, L is the distance, and this L distance we can write multiplicative constant K into A dash B dash. That means into this this reading, K into this reading plus C. That is our original formula. D equals to Ks plus C. Right? That formula we are assuming. But here the instead of D you have to write L. Okay. So similarly here you are applying this equation, L is equals to K into this reading plus C. Now this reading, that is A dash B dash, you have already calculated, that will be S cos theta. So instead of S you have to write S cos theta, right? So this equation will become L equals to Ks cos theta plus C. But again, if you take this bigger triangle, that is OCF, then this is L and this is the actual D and this is at theta. So from this triangle, again you will get D equals to L cos theta. So in place of L, if you put this Ks cos theta plus C and if you multiply by cos theta, then it will become Ks cos square theta plus C cos theta. So original equation, your original equation is Ks plus C, but that will be changed to Ks cos square theta plus C cos theta. So this is the case you have to remember. Now normally what we do in case of calculating our reduced level. Previously, we know that height of instrument minus the staff reading H. That's how we have calculated, right? Here, a little bit modification also is needed. Suppose if you are calculating at this condition, that is angle of elevation. Here, your actual height of instrument is this one from the datum. This is the HI, right? But with HI, you have to add V. Suppose this triangle CF measurement is V. And from that V, you have to deduct H. Then only you can get the RL of E point. So here, your elevation RL of E point will be height of instrument plus V minus H. Where H you can directly calculate from the medial steadier reading, which is you are directly getting. But for V, again you have to depend on this trigonometry. V is basically CF or FC. So that is basically L sin theta, D is L cos theta, so V is equals to L sin theta. But L you already have calculated, that is Ks cos theta plus C. So we will multiply by the sin theta. So it will become Ks cos theta sin theta plus C sin theta. Instead of cos theta sin theta, we can write half into 2 cos theta sin theta, but 2 cos theta sin theta we know sin 2 theta. That's why it is written half Ks sin 2 theta plus C sin theta. So that's how we will calculate the V. So in this way we will calculate the height of the instrument. If your angle of instead of angle of elevation, angle of depression is there, the L, D and V calculation will be similar. Only in case of the RL calculation, instead of plus V, you have to deduct V, because you can see this is the height of the instrument you know. So from that, at first you have to deduct the V, then you have to deduct the H, then only you can get the RL of E. So at the time of angle of depression, you have to calculate by this. So that is the major difference in case of a inclined side and in case of a normal horizontal side. Okay. Some of you at least have understood or at least have followed this trigonometry equation when I am discussing. You can say whether you have understood or not. For the students, those who are unable to follow this trigonometry, please go through the slide. I guess it will be clear. No much difficulty will be there. But still, if you are facing any problem, you can inform me right now. I will discuss that. কোনো পার্টে যদি বুঝতে অসুবিধা হয়ে থাকে, কোনো একটা মিডল পার্টে হয়ে থাকলে ট্রিগোনোমেট্রি বুঝতে, তাহলে কিন্তু পরবর্তীগুলো ফলো করতে হয়তো পারবে না। কিন্তু ব্যাপারটা বেসিক্যালি ডিফিকাল্ট নয়, তোমাকে বেসিক্যালি ট্রিগোনোমেট্রিক ইকুয়েশন অ্যাপ্লাই করতে হবে। ওকে, যদি কারো কোনো জায়গায় কনফিউশন থেকে থাকে সে বলতে পারো, সেই জায়গাটা একটু দরকার হলে ডিসকাস করে দেবো। হ্যালো, এই বুঝাইতো বুঝতে পেরেছো? ওকে, বর্ণালী বুঝতে পেরেছো?
হ্যাঁ স্যার।
ওকে ওকে
স্যার,
হ্যাঁ বলো।
স্যার এখানে এলটা যখন বার হলো সেখানে এল কে এ ড্যাশ বি ড্যাশ এ ড্যাশ সি এ ড্যাশ সিটা তো আমাদের বেরিয়েছিল হচ্ছে এস কস থিটা, তাহলে এ ড্যাশ বি ড্যাশটা 2s কস থিটা হবে না?
না, এ ড্যাশ সিটা তো বেরোয়নি, এ ড্যাশ বি ড্যাশটা তো এস কস থিটা বেরিয়েছিল। দেখো এই জায়গাটা একটু একটু আমি আলাদা কোনো একটা জায়গায় ড্র করছি। ধরো লাইনটা ছিল, হ্যাঁ লাইনটা ছিল এইরকম, হ্যাঁ, আর আমার রিডিংটা পাচ্ছি এইরকম। এইটা হচ্ছে এ ড্যাশ, এটা হচ্ছে বি ড্যাশ, দিস ওয়ান ইজ এ, দিস ওয়ান ইজ বি। ঠিক আছে, তাহলে এ বি ইজ বেসিক্যালি এস, রাইট? Lower stadia minus upper stadia minus lower stadia, AB is basically S, and I am calculating A dash B dash, so that is basically A dash C plus B dash C, right? In place of A dash C I am writing AC cos theta, and in place of B dash C I am writing BC cos theta. Now from both this, if I take cos theta common, it will be AC plus BC, right? But AC plus BC means basically AB, so that is AB cos theta. So AB এর জায়গায় S লিখে দিচ্ছ, তার জন্য S cos theta হচ্ছে। ওকে, okay, so that's all for the distance of the when your staff is vertical but inclined, your side is inclined. Okay, so now the second case which we will discuss, that is your staff is normal. Staff is normal means your staff is held not at 90 degree with the ground, but at 90 degree with the line of sight. Okay, then what will happen? This case is means very easy, as the first part we have discussed. So for the angle of elevation, I am discussing the first case when angle of elevation is there. So in this case what will happen? L will be equals to Ks plus C, because here your L is equals to Ks plus C, because here you don't have to employ this sort of things, because already you are getting this reading. Your staff is held in such a way that this angle is 90 degree. Previously that is not the case. So if this is the case, then L can be easily calculated from the staff intercept. L will be equals to Ks plus C. Now if you see OF dashed from this triangle, if you see OF dashed, you can see this is the L, this is O, this is C, this is F dashed, right? And your staff is like this at the ground, so this is say F dashed. So your OF dashed, this part obviously will be L cos theta. If this is theta, then OF dashed will be simple L cos theta. In place of L we can write Ks plus C. So that's why it is written OF dashed is equals to Ks plus C into cos theta. Now your actual horizontal distance, that is D, which will be equals to OF dashed plus F dashed F. OF dash plus F dash F. So that will be how much? That will be simple. In place of OF dash we can write Ks plus C cos theta, and in place of F dash F you have to calculate. So how we will calculate in place of F dash F? Let us see. You know this reading for the staff, the middle stadia reading you know. That means you know this H, right? You know this H. Now, if you know this H, if you add this F and F dashed, what will happen? See this triangle. If this is theta, this is 90 degree, this will be 90 degree minus theta. Right? And if this is 90 degree, then this will be theta. So if this is theta, in this CF dash F triangle, C F F dash, this triangle where this is 90 degree and this is theta. In this triangle, you know the H, that is basically CF. You know the H. Right? Now from this triangle, if you write sine theta, that will be, some people have means perpendicular divided by hypotenuse. So F dashed by hypotenuse CF. So F dashed will be CF sine theta. Now CF already we know that is H, so it will be H sine theta. So F dashed will be H sine theta, or simply middle stadia reading into sine theta. So that is what we have written. So OF dashed is basically L cos theta or Ks plus C into cos theta, and F dash F is H sin theta. So that's how we will calculate the distance. Now about the elevation of the staff station. How we will calculate the elevation of the staff station. So for that reason, you have to calculate this V. V is basically your CF dashed. V is basically your CF dashed. Now your CF dashed will be how much? For that again you have to look at this triangle. In this triangle this is theta. Okay. And CF dashed will be how much? Simple. As you know, sine theta will be CF dashed by OC. So obviously CF dashed will be OC sine theta. In place of OC, we can write L. So this will be L sine theta. So it will be Ks plus C sine theta. So this will be L, this will be D. Now elevation of the staff will be how much? If you know height of the instrument or the height of the line of collimation, that is this line. Along with that, you have to add V. Then you will get this point. From that, you have to deduct H cos theta. Okay. So from that you have to deduct H cos theta, then you will get the height of the instrument. Why I am deducting H cos theta? Because this part CF dashed you want to deduct. If you know this is H, this will be H cos theta. So simple, from the height of the instrument, if you add CF dashed, you will get this point's height. From this point, if you deduct this, here I am writing instead of E, I have written F, whatever the reason. If you deduct this height, then you will get this actual height, right? So for that reason, you are deducting H cos theta. So in this way, we will calculate the elevation of the station point. Is it clear? কোনো জায়গায় যদি বুঝতে অসুবিধা হয়ে থাকে বলতে পারো। বোঝা গেছে? কি সবাই বুঝতে পেরেছো? মাথার উপর দিয়ে যাচ্ছে। প্রবল?
হ্যাঁ স্যার।
প্রবল বুঝতে পেরেছো?
হ্যাঁ স্যার বুঝেছি।
হ্যাঁ বুঝেছি। বার খাতায় করে নিলে আরো ভালো।
হ্যাঁ, খাতায় এগুলো প্র্যাকটিস করতে হবে, নাহলে তো হবে না। ওকে, আচ্ছা। এরপর আসবো the second case of the similar one, that is your staff is normal but site is inclined, but right now the angle of depression is there. So similarly, L will be Ks plus C. Instead of L or wave dash, you can write L cos theta, that is Ks plus C cos theta. Only the thing is that D is OF dashed plus F dashed F in the previous case for the angle of elevation. Here it will be OF dashed minus F dashed F. Because if you look at the diagram, then its actual horizontal distance will be OF, and which is basically the actual distance D, if you want to calculate, it will be basically OF dash minus FF dash. Sorry, if you are calculating D, this mark is wrong. OF dash minus FF dash. OF dash minus, this mark is getting wrong. D mark. D mark is actually wrong here. D mark will be up to this one. OF. OF is your D. This marking is wrong. So D is equals to OF, which will be equals to OF dashed minus FF dashed. And that's why OF dashed you have already calculated, that is Ks plus C cos theta. That will be simple. Similarly as you have calculated in the previous case. But this FF dashed, that is H sin theta, which earlier you have added, right now you have to deduct in case of the angle of the depression. That's all. And for this elevation of the staff level, the V you have added, here you have to deduct the V also. So RL of E is actually height of the instrument. Previously it is plus V, right now it will be minus V, and H cos theta obviously will be minus. If you look at this triangle, it will be clear because this is the height of the instrument with respect to a particular datum. So if you deduct the V, you will get up to this point. From this, if you deduct the H cos theta part or simply this part, then only you will get up to this point, right? H cos theta or up to this part, if you deduct, then you will get up to this point. So that's why both the things are we have to deduct from the height of the instrument. Okay. So in this way, we will calculate our RL and our distance. Okay. Now let us do these numericals. This will be last slide for today's class. Let us do these numericals. Please be ready with the pen and paper and note down the data. Once you have noted down the data, you can inform me. So what is written? Please go through. A tachymeter was set up at station A. Suppose this is our station A. A tachymeter is set up here, and the readings of vertically held staff at B you are taking 3 staff reading. Vertically held staff at B were 2.255, 2.605 and 2.955. So the line of sight is inclined. I have drawn like it is almost vertical. It will not be like this. So it is here. So the line of sight is, say, like this. Okay. Then you are having upper and the lower. Like this. 3 readings you are getting. So from the horizontal, your middle stadia readings is at an angle theta. So that is given when you are taking your staff reading at point B, that is 2.255, 2.605 and 2.955. And the angle of inclination was theta is given as 8 degree 24 minute plus. Another observation on the vertically held staff at a benchmark. Similarly, you have done another staff reading at benchmark, and there is also some reading 1.640, 1.920 2.200. The inclination of the angle at that time is 1 degree 06 minutes. So I have drawn only one case, but because the second case also will be similar. So 1 degree 06 minutes. Now calculate the horizontal distance between A and B and the elevation of point B if the RL of the benchmark is given. The constant of instrument is also given. So please note down this data, and once you are done copying this data, please let me know. সবাই ডেটাকে লিখে ফেলো, তারপর আমাকে বলো।
ওখানে থিটাটা বলে দিয়েছে, একটা 8.24 আর একটা 1.06।
রাইট, নোট ডাউন হয়েছে ডেটা? সবার কি ডেটাগুলো নোট ডাউন হয়েছে? ডেটাগুলোকে নোট ডাউন করো, তারপর আমরা সেম প্রবলেমটাকে করব। So first we will see our first point will be, এই সবার নোট ডাউন হয়েছে? ডেটাগুলো নোট ডাউন করেছো কি না টাইম লাগবে? So first is our observation on benchmark. Observation on benchmark. Here what we will do, so this is our stuff we are holding at benchmark, and say this is our middle here, this is our upper here, and this is our lower here. Benchmark's RL is given, that is 418.685, and lower steady is given, reading is 1.640, middle stadia is 1.920, and upper stadia is 2.200. Also the middle stadia, if you see middle stadia is at an angle with the horizontal at 1 degree 06 minute, plus 1 degree 06 minute. So what we can do from here, we can directly calculate the V, the formula we know. If you remember the formula here, what is happening? The staff is held vertically right at 90 degree, right? So the first case 1 we are talking about. In the case 1, if you see, the V is half case sine 2 theta plus C sine theta. So that we will apply. So V equals to half Ks sine 2 theta plus C sine theta. You know the theta, so please calculate this V. You know the K, you know the S. S will be how much? 2.20 minus 1.640. So 2.200 minus 1.640. Calculate the S, then put in this equation. You know the K as 100, you know the C as 0.3, you know the theta, so you can calculate the sine theta and cos this cos theta, sine theta and cos theta also. So you calculate V টাকে calculate করো।
1.081.
So it will be 1.081 meter. Now I want to calculate only this height of the instrument at this instrument station, right? So the elevation of the line of collimation at this point, that I want to calculate. This line is inclined. I only want to calculate the height of the instrument. So height of the instrument at instrument station or the elevation of the line of collimation at the instrument station will be how much? It will be simple. It will be your RL benchmark RL plus your middle stadia reading, okay, because it is holding at 90 degrees. So RL plus this reading, so this much you are getting, that means plus 1.920 and minus this V1. Minus you will deduct this V, because you see your V is how much? Yeah, so this is the case. So if you deduct your V, then you will get this height of the instrument. Right now, RL of this point we know. Along with that, we have added H or the middle stadia reading. You have to deduct minus V. So here, with the RL, you are adding H and you have to deduct the V. Why? Because you want to calculate this height of the instrument at instrument station. So benchmark in the RL is 418.685 plus height middle stadia reading you have no 1.920 minus your V which you have calculated 1.081. So please calculate how much is the height of the instrument at instrument station. Height of the instrument at instrument station. At instrument station, height of the instrument is equals to. Is that clear? Why height of the instrument will be this much? Because already you have with this benchmark you are adding this much amount, then we'll deduct
419.524 meter.
419.524.
Yes, sir, 524.
Okay. Now we will do observation at B. So now height of the instrument is fixed. This one is fixed. Now observation at B. Now observation of B, calculate the S first. S will be how much? We know that it is 2.955 minus 2.255. So 2.955 minus 2.255. Calculate the S. You know the theta, that is 8 degree 24 minute. So you can easily calculate the D, which we know D is equals to Ks cos square theta plus C cos theta. You know the K as 100, C as almost 0.3 is given, I guess. You can calculate, you know the S from here, it will be 0.7. So from that, calculate the D. ক্যালকুলেট করলে কেউ? সমজিৎ, বুধাদিত্য, কেউ একজন বলো। বুধাদিত্য করছো?
হ্যাঁ হ্যাঁ।
হ্যাঁ, কত এসছো বলো।
68.8.
68.8. Okay. 68.8 meter. Now here also you calculate the V. V is the calculation is similar. V is equals to half ks sin 2 theta plus sin c sin theta. So calculate here also V.
Point 087.
V is 2.087.
0.087.
0.087 meter. Okay. Now we have to calculate the RL of point B. So what is the formula? You can see RL of point B will be height of instrument, which already we have calculated from the benchmark station, plus V minus H, as the angle of elevation is there. If angle is depression, angle of depression is given, or instead of plus minus is given, then V will be minus.
10.16
So it will be HI plus V minus H. HI plus V minus H. So calculate minus H means minus
Sir,
2.605.
sir, 10.1.
V টা কত আসছে?
10.16
তাহলে 0.087 কে বললে? আচ্ছা 10.16 তাই তো? হ্যাঁ, তাহলে V টা যদি এখানে মাইনাস করো, V টা প্লাস করো 10.16, আর HI টা আমাদের কত ছিল আগের স্লাইডে বের করেছো? 419.524. So 419.524.
হচ্ছে কেটা গুণ করতে ভুলে গেছিলাম।
ও আচ্ছা আচ্ছা। Now calculate here.
ফোর টু 7.079.
কত এসছে বলো আরেকবার?
427.079.
Okay, so RL of point B is 427.079. So that's how when the site is inclined we will calculate, and if the site is not inclined, staff is also vertical, then it will be very easy to calculate, right? Simple. You don't have to apply even this theta and all these things. Okay. So that's all for today. Next day we will again, in the Monday we'll meet and we will discuss about we'll continue our discussion about the tachyometry, mainly the tangential method I will discuss, and I will discuss few more numericals from this part. So today I will upload this note. Please go through this, the trigonometrical equation you have to go through, and please try to write down in a notebook, try to practice, then it will be better. Otherwise equations you will forget. Okay, the derivation you will forget. So that's all for today. If you have any question you can ask, else we are done. The link for attendance is given in your chat box.